Let's do our third, and I think this will probably be the final video for the first section, Introduction to Quadratics. Yeah, so this one will focus on the back of the notes handout that you have. I think 3 problems. So let's take a look at that. All right, so let's see, zoom in. That looks pretty good. All right, let's go with that. All right, so our directions here is we're going to take each quadratic function and determine whether the parabola opens up or down, whether the vertex is a maximum or a minimum, very much related, and then finally the approximate coordinates of the vertex. And so for that, we're going to use a graphing calculator. We do have some other methods using algebra, but since this is an introduction, let's get comfortable with the technology. All right, so this one already appears to be in standard form. So let's practice our ABCs here. So it looks like A is a -1, B is also a -1, and C is a 6, positive 6. Great. So if you remember what we were talking about earlier, C is going to be my y-intercept. So let's see, 0, 1, 2, 3, 4, 5, 6. So I know that the graph is going to go through this point. It's not a lot of information, but it's something. So this is my y-intercept. And then the first 2 parts, A and B of the directions, all have to do with the coefficient of x squared, so our A value. So because this A value is negative, that means it's going to be a frowny. It's going to open down. So I know that. So I know that this parabola opens down. And since it opens down, right, that means that the vertex is going to have to be the highest point. So the vertex is the maximum. Great. So we know those 2 things. Now let's use our graphing calculator and maybe figure out some other critical points, and particularly the vertex. So I've got my graphing calculator here. Hopefully this shows up pretty well. Oh, it looks kind of fuzzy. Oh, okay, I don't really like that. Oh, that's better. All right, so let's go back to, so I'm in the y equals menu. I've already entered my quadratic, so there it is. Why don't you try the same thing? And so here's my quadratic. So now I'm going to go ahead and look at the graph just to see what it looks like. I already have an idea. Opens down. Y-intercept at 6. There it is. Yep. So it looks consistent. This one has 2 x-intercepts. So one looks like it's approximately 2 and approximately -3. So I'm not looking for those details yet. Like I said, there's going to be like many ways that we can find those exactly, but we're just sketching a graph for now. So I'll go ahead and drop in those points for 2, +2, and -3 here. Since this thing is symmetrical, right, the left side is going to be a reflection of the right side. If I look at the halfway point between these x-intercepts, I know that is where my axis of symmetry is going to be. So at -1/2 for an x value. It's kind of good to know, just intuition-wise. We do have a formula for that, but we won't need that for a little while. I'm just working on intuition here. All right, so there's my axis of symmetry. So I think I have a pretty good idea of where my vertex is, but I'm going to go ahead and use my graphing calculator, practice using the tool. So right here on the trace button, there is the blue calculate. All right, and we've used that for a few things. We've used that to find zeros, also called x-intercepts. We use that to find intersections of systems of equations. And just lost my light there. There we go. And we've also, what else? I don't know. I feel like we did some other things with it. I mean, generally, we've used this for a few things. So let's go ahead and go to that menu. And since this one opens down, we're looking at number 4, a maximum. So again, I'm in that calculate menu right here above the trace button. So we're gonna choose number 4. So I'm gonna push 4. So now I'm looking for a maximum, and it says even at the top, calculate maximum, and it tells me what function I'm looking at. All right. So if you look down at the bottom of the screen right here, it's saying left bound with a question mark. So it's asking you to choose a value on the curve that is to the left of the vertex. So this is very clearly to the left. So I'm going to hit enter here, and then it's going to switch my question. And now it's asking right down here, what is the right bound? What is a right boundary? And this is, again, just sort of narrowing it down for your calculator so it doesn't have to consider all possible values. It's only going to look between these two, right? And it even shows me with the arrows, like, I'm going to look between these two. All right, so now it just says take a guess. You really don't have to take a guess. You could just hit enter, but I'm going to go ahead and be pretty deliberate. All right, so there is a good guess. I'm going to hit enter. And, oh, it tells me maximum. Looks like it's right at negative 0.5, which is something I already knew, and positive 6.25. So I'm going to go ahead and write those down as the vertex. So it would be right around here. Comes down here, an arrow. This curve comes down here with an arrow. And my vertex is at negative 0.5 and then 6.25. Awesome. All right, so again, in the directions it says approximate, so that's actually exactly it, but don't feel the need to write a huge list of decimals here. You can round to the hundredths to the second decimal if you like. This is an approximate value sometimes. Right? All right, so that's the first one. Let's go ahead and try it again with the second, and then I'll have you do the third on your own. All right, so let's go ahead and move this down. Okay, here's a new quadratic, another one. I recognize it's a quadratic because it has a x squared as its largest degree. Okay, there we go. All right, so let's go ahead and do our ABCs. A is 2, x squared. There's an invisible 1 here, that's 1x. So B is a positive 1. And then there is no C over here. So that means C equals 0. So that also means, right, that's supposed to be my y-intercept. So that means this graph will travel through the origin. So that's also an x-intercept. And I'm not sure at this point if there's one x-intercept or two, but there's at least one, and it's right here. It's also a y-intercept. All right, so we have that. Since A is positive, A is greater than 0, it means A is positive. Therefore, this parabola opens up. And since it opens up, it's going to be a U shape. That means the vertex is going to be the lowest point. So the vertex is the minimum. Okay, just some quadratic basics. All right, so now let's go ahead. I mean, I could make a t-chart here and just crank out a bunch of numbers, probably between -4 and +2, somewhere in this area, and graph it by hand. But I do have a calculator. I can use this as well. So I'm going to go ahead and go back to my y equals. I'm going to enter this new one. Let's clear that out. All right, this new one is 2x squared plus x. So here is 2x squared plus x. And so let's go ahead and take a look at the graph. Oh, there it is. Wow. So it looks, man, if I look really closely, it looks like I think there are gonna be two x-intercepts here. I think it just barely crosses and then comes back up. It looks like it dips just barely below the line. So go ahead and look at that closely. Yeah, I'm pretty sure. So let's go ahead and be sure about it. I'm going to show you. Let's zoom it. I'm going to zoom in. And I'm going to focus right in on that little spot. So I can move my cursor around to the center of my zoom. So I'm going to go right to that little spot close to the vertex and then hit enter. And it'll zoom in tight. Yep, see it dips below just a little bit. So this one has two x-intercepts. And it appears that the vertex is right here. So let's go ahead and find it. So I'm going to use the calculate button again. So calculate. This one is a minimum. So I'm going to go down to minimum. And left boundary, enter. Right boundary, so go to the right of the vertex, enter. Then let's go close to the middle. Looks good. All right, so this looks like it is negative 0.25, negative 1/4 is my x value, and looks like negative 1/8, which is 0.125 is a decimal. So it does just barely go below the x-axis. All right, so let's go ahead and label that. Right right here. So that will be negative 0.25 and negative 0.125. So there's my vertex. Since I want to like sketch a decent graph here, I could just sort of estimate it based on what I see visually, but we can be a lot more exact than that. So I'm going to go ahead and go to the table, which is right here above your graph button in blue. So I'm going to look at my table, and here's a whole bunch of values. So I'm going to go where my x values are closer to 0. Just see what I have. Okay, here are some I can graph. All right. Oh, that looks nice. All right, so here's some I can graph. So I'm going to plot these points. Negative 2, 6 up here. And it looks like there's a negative 1.5, 3 here. And negative 1, 1. And this one, let's see, 1, 3. And 1.5, 6. There. That's a much better than just a rough sketch. I'll try to connect those with a smooth curve if I can. I don't have a benefit of a straight edge here. I mean, it won't help me with quadratics since these are curves. All right, that's pretty good. That'll do. Awesome. So there's a good rough sketch of the graph, and the vertex is clearly labeled. Now it's even more clear. Awesome. So let's go ahead and pause the video for a minute while you try the third example on your own. Get your graphing calculators, use your partner sitting next to you, and then do it in pencil so that if you make a mistake, you can correct it. All right, so why don't you go ahead and work on that now. All right, so here's the third one. Hopefully you had a chance to finish that up. Excuse me. This one's not in standard form, so I'm going to go ahead and rewrite it in standard form. My x squared term is first. That's a negative x squared. So a must be a negative 1. My x term is negative 3x, so it's minus 3x. And then, so that means b is a negative 3. And then my constant is a positive 2, so I'll go last. So there it is in standard form. And so that means c is positive 2. So I know I have, why is that not focusing? Come on. I don't know what just happened, but it's refusing to focus. Please focus. Thank you. This is not voice activated. I don't know why it listened to me. Okay, so I know that my y-intercept is positive 2. Because my c value is a y-intercept, so I can drop that point in without having to use my calculator. I also know because a is negative, right, that this opens down. It's a frowny. And I know that the vertex must be a maximum. All right, so let's go ahead and use a calculator to figure out exactly where that vertex is. So I'm going to go back to my y equals. This is from my previous one. Let's clear that out and enter my new. I could enter it just as the original problem was given to me, or I can enter it in standard form that I rewrote. Either way, it doesn't really matter. I guess I could just go to the original because there's no way I could mess that up, I hope. So negative 3x plus 2, and then minus x squared. Give you a chance to type that in. And so I know that I'm, well, I'll just go to the graph. I know that my graph is zoomed in on an area from my last one. So if you'll recall the way that we can go back, oh, there's a piece of it. Oh, look, I can see my y-intercept is positive 2 right there. All right, so I knew I was zoomed in from my last one. So just a reminder of how to go back to the standard 10 by 10 positive and negative axes. If you go hit the zoom button and you look at number 6. So zoom is right here. Zoom. It gives me my zoom menu. Number 6 is standard, so it goes back to the positive 10 and negative 10. So I can either scroll down or I can hit the number 6. And that will take me back to that. Excellent. So this one has 2 x-intercepts. It opens down, and so let's find the approximate coordinates of the vertex. So I'm going to go to the calculate menu. Hopefully you've already done this. And I want a maximum since it opens down, so number 4, maximum. And this is where it's saying left boundary, hit enter. Scroll over to the right side, right boundary, hit enter. And then it says take a guess. Fine. There we go. There's a guess. All right, so it looks like I have a maximum at -1.5 and +4.25. So -1.5 and +4.25. So that's my vertex. If I want to find out what my x-intercepts are, just to show you, in that same calculate menu, I can go to 0. So the reason this is called a 0 is because when the height or the y value is 0, right? So x-intercepts are always 0, some x value and then 0 for the y. So the x-intercepts are the same as zeros. Those are synonymous. All right, so now it's going to go through the same options, but now I'm going to narrow it down based on the intercept, not the vertex. So now I'm to the right. I'm focusing on this left intercept, or 0. Take a guess. It tells me it's -3.56. All right, so it's approximately halfway between -3 and -4. So right about here. That'll work. And let's go ahead and look at the other one. Back to calculate. Calculate is 0 again, but this time it's going to be the one on the right. So I need a left boundary. That'll work. And now let's pick a spot past the intercept. There it is. And then back in and take a guess. All right. There it is. 0.56. So right about here. I guess I can write it as a pair. All right, so I've got those critical points. Oh, I never actually graphed this. -1.5, and then 1, 2, 3, 4.25. Right here. So those are critical points. Vertices, or the vertex, and then each intercept you can find. And if you just feel like you don't have quite enough for a graph, then use your table to pull in a few more, just so you're not so you're being accurate. You don't want to be too rough and vague with your graph. All right, there we go. So there's a third example. I hope I know based on the homework that I assigned, these examples from the first 3 videos should help a lot. Besides in class, I'm hoping to get them on YouTube. So if so, then you can get links for the YouTube videos.